Hello and welcome to Lesson 1-6, that's Chapter 1, Lesson 6, Relations. So today we're going to be talking about different ways to represent data. This one's going to be kind of long, and I apologize for that in advance. But we have basically three different ways we're going to try and represent data, and it's going to be by a table, graph, and mapping. So let's start with a table. For a table, I'm going to create a, table with x's on the left, y's on the right. So for the information they give me, I'm just going to write the x's on the left and the y's on the right. It's as easy as that. So the biggest thing that's important to know then is that points are written in the form x, y. So if it says 4, -3, 4 is the x, and -3 is the y. My pen stopped working for some reason. Here we go. X and y. So 4, -3. Do it again for the next point. 3 and 2, this is your x, this is your y. 3, 2. -4, 1. 0, -3. Pretty cool, huh? Graph, hopefully you've done this before. Most of you will know what to do already. Just graph the 4 points. Remember that you run before you jump. Go across the x-axis and then go across the y-axis. This is the x-axis, this is the y. So if the point is 4, -3, go to the right 4, 1, 2, 3, 4, and down 3, 1, 2, 3. Okay. Now try it the other way. Or try the next point. 3, 2 means go right 3, 1, 2, 3, up 2, 1, 2. Put your point there. -4, 1 means go over 4, 1, 2, 3, 4, up 1. Notice since it was negative, I went left. 0, -3, that means go left and right 0, go down 3 since it's negative. Like so. All right, then a mapping. This is pretty cool. Draw a bubble, and draw a second bubble. And I want you to write the x values in the first bubble and the y values in the second bubble with one catch. Don't write duplicates more than once. So like for x's, everything's normal. Just write your 4, your 3, your -4, and 0. But notice for y, you see how I have you see how I have 2 -3s? Okay, let me draw some arrows at them in case you can't see them. Only write it once. So -3, 2, 1. Oops, I already have -3 written, so I don't have to write it again. Now I want you to just draw an arrow to what the left number goes to on the right. So over here it says that 4 goes to -3. 4 goes to -3. 3 goes to 2. -4 goes to 1. 0 goes to -3. It gets to do a crisscross line, and that's it. Pretty crazy. So when it says to determine the domain and range, what we're looking for here, domain is the x values, range is the y values. And again, you're only going to write them one time like you did over for the mapping. So here my domain, I'm going to write domain equals 4, 3, -4, and 0. Range is going to be an R, and it gets to be -3, 2, 1. All right, that's the first part of this today. Next up, identify the independent and dependent variables for each relation. So for this, the independent variable is going to be what we change, or what we can change. Or we change what we're looking at. The dependent variable is what happens when we change that. So the air pressure inside a tire increases with the temperature. So what are we changing, or what are we pretending that we change in this case? increases with the temperature. We're changing the temperature. Okay, so whether it's colder outside or hotter outside, the temperature causes the air pressure to change. So the temperature is going to be the independent variable, and you can just write IND. The air pressure is going to be the dependent variable. Okay? 2b, as the amount of rain decreases, so does the water level of the river. Does it make sense this time that I am changing the water level in the river? Probably not, but Mother Nature changes how much rain we get. So in this case, amount of rain is going to be the independent variable. Water level will be the dependent variable. All right, this next part I think is fun. We get to actually read some graphs here and determine what's going on. Now you'll notice there's no numbers, but that's okay. I'm not really worried about specifics here. I'm worried about just the general idea. So as time goes on, the distance should be changing here. And it looks like for the most part the distance is increasing. Tell me a story about it. So like right here, it looks like we go pretty fast. So maybe we're driving to school, like it says, and we're driving on the highway. Now what happens here? We have a flat line. Time keeps going, but we don't increase distance. So give me an example of why that would happen. Maybe we hit a stop sign. Not hit a stop sign, but had to wait at a stop sign or had to wait at the stoplight. Okay. Then we were in town, so that's why we're not driving as fast. See how it's a slower slope than over here? Okay. Then we had another stop sign, and then we continued driving in town. I don't know, something like that. For these ones, you're going to actually write that story out. So I was driving on the highway. When I stopped at a stop sign. Then I drove in town to the stoplight. Oops, I got my letters mixed up there. Then continued driving. Okay. Same with income over here. Steady income, maybe works hourly. Had a very high increase in tips or hours. I'm not sure, due to the holiday maybe. Maybe it was Thanksgiving, so I had to work Black Friday. Okay. Then continued working through December. Got sick, so I didn't work for a few days, so I didn't have any income. Then I continued working. Something like that. All right, that is it for today.